Balance the following redox reaction that takes place in basic solution using the half reaction method. So basic solutions are not much different than acidic solutions when solving half reactions. However, at the end you have to do something different with your H pluses. You basically neutralize them with OH minuses, and your final balanced equation will have OH minuses in them instead of H pluses. So a lot of the steps are the same as in the acidic solutions, so I'm going to gloss over some of that and focus more at the end. If you need help with that, look at some of the balancing half reactions in acidic solutions, and also finding oxidation numbers as well. So I'll assume that you know some of that. So the first step then to balancing any redox reaction is separate it into the two halves. So in this case, the reduction half is the MnO4 minus, turns into MnO2, and the half oxidation is the SO3 2 minus, turns into SO4 2 minus. So again, look at the oxidation states example if you're not sure why which half is which. So again, like with any redox reaction, you balance everything that's not a hydrogen and not an oxygen first. So if we look at this, we see that there are equal numbers of manganeses and equal numbers of sulfurs. The rest are oxygens, and so we don't need to do anything else there. Next, we add H2Os to balance out the oxygens. So in this reduction half, we need to add 2 H2Os so that we now have 4 O's on both sides. And in the oxidation half, we need to add 1 water to the reactant side in order to balance out the oxygens. Next, you do the hydrogens, and you do that by adding H pluses as before. Now, you might say to yourself, H pluses, that means it's an acid. I thought we were doing this in basic solution. The math is basically the same here, and the chemistry is basically the same, so that you can do this sort of as a placeholder, and like I said, at the end, you'll switch them into OH minuses. So just to keep it simple, we will keep doing what we already know, and then we'll fix it sort of in the end. So when I look at these two half reactions, I see that I have 4 hydrogens on the product side in the reduction half, so I'll add 4 H pluses there to balance those out. And I need to add 2 H pluses on the product side of the oxidation half. So far, so good, all still the same. Lastly, we need to balance out the charges. And so on the reduction half, we have 4 pluses and a minus, which makes an overall charge on that side of +3. And then on the other side, we have 0 and 0, so we need to add 3 electrons on that side so that we have an overall charge of 0 on both sides. Remember that 0 is nothing special about 0, they just both have to be the same. And you can't add negative things to 0 to make it more positive, so you have to do it on the reactant side in that case. For the oxidation half, we need to add 2 electrons to the product side in order to balance out the charges there. You'll notice there's a -2 here on the SO3 on that side, and a -2 and a +2, which is 0 on that side. So to get that down to -2, we add 2 negative electrons. Now recall that these have to be the same. Since this is actually all one reaction, we're just looking at it in two halves. There's 3 electrons on in this half reaction, there's 2 in this one. So what we need to do then is multiply everything by 3 and everything by 2, so that we'll have 6 and 6, or the same number on both sides. So when I do that, I'll do this down here. I get 6 electrons plus 8 H pluses plus 2 MnO4 minuses make 2 MnO2s plus 4 H2Os. And for the oxidation half, I get 3 H2Os plus 3 SO3 2 minuses, sulfites, 3 sulfates, 6 H pluses, and 6 electrons. So now that we have those all evened out, we've got the same number of electrons on both sides, we can combine the two halves again. So again, none of this has been different thus far from acidic solution. So we put it all together and cancel out what we have the same on both. We get 6 electrons. Remember, the order here doesn't matter which halves you do, as long as everything that's a reactant side stays on the reactant side, and everything that was on the product sides stay on the product sides. And then that makes 2 MnO2s plus 4 H2Os, and I'll do this down here. Just save room. 6 electrons. Okay, so now we can cancel out what's the same on both sides. Remember, your electrons should always cancel out. If they don't, you've done something wrong. I got 8 H2 or H pluses here and 6 here, so that leaves me with 2. I have 3 H2Os and 4 H2Os, so now I'm left with 1, and they're gone, and everything else remains the same. Now, this is when you deal with your H pluses and convert them to OH minuses, since this is supposed to be taking place in basic solution. Basically what you do is you look at your H pluses and you combine them with an equal number of OH minuses to make water. So I'll add 2 OH minuses here, and what I do to one side, I must do to the other. And so if I write this all out again with everything eliminated, this turned into 2 H2Os, my 2 H pluses plus 2 OH minuses make 2 H2Os, plus 2 MnO4s, plus 3 SO3, 2 minuses, plus 1 H2O, remember that there, and then plus our 2 OHs that we added to both sides. Now we're almost done. Just be aware that now we can cancel again some waters because we have water on both sides. We got 1 here and 1 here, and so our final solution in basic medium here is H2O plus 2 MnO4 minus plus 3 SO4 2 minus make 2 MnO2s plus 3 SO4 plus 2 OH minuses. And there you have it. So really the only extra step is once you get to the final part where you would have been done when you were doing this in acidic solution, you simply convert your H pluses by adding an equal number of OH minuses to both sides, turning the H pluses into H2Os, and then if you have to cancel out waters again, you do so, but your final answer should have OH minuses in it somewhere instead of H pluses.